Hello everyone, my name is Arnav and today we'll be going over the Invitational A from the 2023 to 2024 of the UIL Science exam. Today's video will be covering the physics section. Before I show you guys all the answers to and solutions to each question, I would like for you guys to try the exam yourself. These are the questions from numbers 1 through number 9, number 10 through number 16, number 17 through number 20, and a formula sheet that has all the useful constants that you will need for the exam. Numbers 1, 2, and 3 are going to be from the reading 5 Equations That Changed the World by Michael Gillen. The answer to number 1, who was the rival that Isaac Newton was decided not to publish his ideas concerning light? That's going to be Robert Hooke. Number 2, Halley was overjoyed about Newton's equation of gravity because it helped make sense of it. Newton's equation of gravity helped make sense of the behaviors of comet, and Halley was overjoyed by this because it helped with his calculations on the gravitational force on the comets. And number 3, the complicated problem that Gillen is talking about is going to be the three-body problem, because calculating the gravitational forces on 3 different celestial bodies is mathematically very difficult and can only be approximated with an answer, not given an exact specific number. So the answers to number 1, 2, and 3 are going to be C, C, and E. Number 4. Only one moon in our solar system has a thick atmosphere. It is also the only nitrogen-rich, dense atmosphere found anywhere in the solar system. Which moon does this describe? The question is describing Titan, which is a specific moon on the planet Saturn. Titan has an atmosphere similar to Earth. It is high, it's very thick, and it has a lot of nitrogen in it. So the question for number 4 is going to be A. Number 5. A domestic cat is chased across the yard by a domestic dog. You observe that the cat crosses the entire 18-meter length of the yard at a time of 4.5 seconds. How fast was the cat running in miles per hour? So we know that the cat traveled 18 meters in 4.5 seconds. So converting that into meters per second, that would be 4 meters for every 1 second. But we don't want to find in meters per second. We want to find the answer in miles per hour. So 4 meters in 1 second. Let's convert seconds first, since it's a bit easier. How many seconds are in an hour? There's 3,600 seconds in 1 hour. So we got the hour part now, but now we want to convert meters to miles. There is 1,609 meters for every 1 mile. So plugging everything into a calculator, we would get 8.95 miles per hour. So the answer to the question is D, 8.95. Number 6. A domestic cat, starting from rest, accelerates at 3.5 meters per second squared. The cat reaches its final speed after traveling a distance of 2.6 meters. What is the final speed of the cat? For this problem, we're going to need to use one of the kinematic equations. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. So we're trying to find final velocity. So what is each of the values? What are each of the values? Initial velocity, we know that it's starting from rest. So initially it's not even moving. So the initial velocity is 0 meters per second. What is acceleration? We know it's acceleration 3.5 meters per second squared. What is displacement? Traveled a distance of 2.6 meters. So we have everything we need for this equation. Plugging everything into the equation above and solving for final velocity, we get a value of 4.266 meters per second. So the answer to this question is going to be A, 4.27 meters per second. Number 7. A bag of cat food slides without friction down an inclined plane. The angle of the incline is 28 degrees and the mass of the bag of food is 3.3 kilograms. What is the acceleration of the bag of cat food down the incline? So let's draw all the forces on the bag of cat food. So we have our incline here. We have the cat food. And we know the forces, there's going to be a weight force. I'll draw with a blue arrow, a weight force. And a normal force perpendicular to the plane. I'll draw with a red arrow. So those are the two forces. We know the weight force can be broken down into two components. We're going to have a component parallel to the incline of the plane and a component perpendicular to the incline of the plane, just like the normal force. So these make a right angle. So I know my figure is completely not drawn to scale, but the normal force and this brown arrow cancel each other out. So with that in mind, the net force is going to be, because the blue arrow is a component, so we can actually erase it. If these two cancel out, the net force is just this green arrow, just the parallel weight component on the block. How can we find that component? Let's redraw our triangle. So we have a green line, blue, blue, green, and brown. So we know the blue line's a weight. What is going to be the weight? The weight is mass times gravity. If you guys didn't know, this angle here is equivalent to the angle of the incline because of similar triangles. So these two angles are equal. So then, based on trigonometry, this would be mass times gravity times sine theta. This would be mass times gravity times cosine theta. So the normal force is equal to the mass times gravity cosine theta. So because both the forces are in opposite directions, they cancel each other out. So we're only left with mg sine theta, pushing the cart downwards. That means net force is equal to mass times gravity times sine theta, because that's the only force that's not canceled out, because we can break the blue arrow into the components and the brown component is canceled out with the red arrow. So there's only the green arrow that's still there. But how does that help us find acceleration? We know net force is also equal to mass times acceleration. That's Newton's second law. So we can divide both sides by mass. We're going to get g sine theta equals acceleration. We know g is equal to 9.8 and theta was 28 degrees. So plugging that into a calculator, you can get acceleration equals 4.6 meters per second squared. So the answer to this question is going to be B, 4.6 meters per second squared. Number 8. A cat toy with a mass of 220 grams slides across a horizontal floor. The coefficient of friction between the cat toy and the floor is 0.32, and the toy slides a distance of 4.5 meters before coming to rest. So how much work was done by the force of friction? So if we draw our scenario out, we have the cat toy. It slides across the floor, so we have velocity. It's going to the right, and friction opposes the toy's motion. So the red arrow is going to be the force of friction. So eventually the box stops. Eventually there's no movement. So the force of friction is providing negative work on the box. We want to find the work. And by the way, even though it's negative work, all the answers are still going to be positive. We're just trying to find the magnitude of the work. We don't really need to care about the sign or not. So how do we find the net force? Actually, not the net force, the force of friction. The formula to find force of friction is going to be the coefficient of friction times the normal force. Remember, when a box is standing on a flat plane, the normal force is equal to the weight of the box. So you're going to have normal force equals weight. So what is the weight? The weight is equal to mass times gravity. That means this formula can be written as coefficient of friction times mass times gravity. Plugging everything into the formula, coefficient of friction is 0.32. Mass, remember mass has to be in kilograms. So 220 grams is equal to 0.22 kilograms. And gravity is always 9.8 meters per second squared. Plugging everything in, you can get a force of 0.669 newtons. That's the force that's the force of friction on the block. But we don't want to find the force, we want to find work. So what is work? Work is equal to force times displacement. We know the force, that's 0.69. What is the displacement? How much has the block moved? It says that the box has slided a distance of 4.5 meters. So plug 4.5 here. You can get 3.1 joules. So the answer to this question is going to be letter C, 3.1 joules. Number 9. A metal beam is arranged horizontally with a fulcrum located 1.4 meters to the left of the center of mass. A 25 kilogram mass is attached to the beam at a location that is 3.25 meters to the left of the center of mass. The system is perfectly balanced. What is the mass of the metal beam? So, what are all the this problem relates to torque. So what are all the forces on this beam? We have a weight force of this block here, and we have the weight of the center of mass. I'll even draw that in red. We have the weight of the center of mass on the fulcrum. On the beam. So those are the two forces. We know that if the system has to be perfectly balanced, that means the torques are going to be equal. So the clockwise torque has to be equal to the counterclockwise torque. And we know, and if you guys haven't known yet, torque is equal to the force applied to applied to an object times the radius or the distance between the pivot point, which I'm drawing in green, to the force. So this right here will be the radius, times sine theta, which is the angle between the force and the radius. So in this case, theta is always going to be 90 degrees. So we can ignore sine theta completely. So what is clockwise torque? Clockwise torque is essentially torque that makes the object rotate clockwise. If you can imagine this system in real life, this red arrow is what's making the object move clockwise. So we know the center of mass is essentially where all the weight is at. The weight is going to be located, or in physics, we draw the weight as located at the center of mass. So what is the formula for weight again? It's mass times gravity. We're trying to find the mass of the beam, and gravity is 9.8. That's the force. That's this red arrow. We want to find the distance between the red arrow and the pivot, which we're given as 1.4. So 1.4. What about the counterclockwise torque? We do the same process for that. We find the force, this blue arrow. That's the weight force of the block. Weight is equal to mass times gravity. So the mass is 25, gravity is 9.8. And what's the distance between this blue arrow and the pivot point? Pivot point's here, blue arrow's here. That's going to be, we know this entire length is 3.25, and this length here is going to be 1.4. Subtracting the two numbers, 3.25 minus 1.4. So 3.25 minus 1.4. That's the radius. And then we set these two equations equal to each other. So mass times 9.8 times 1.4 equals 25 times 9.8 times 1.85. Solving for mass, you would get an answer of 33.04 kilograms, which rounds closest to letter C. So the answer to number 9 is going to be C, 33.0 kilograms. Number 10. You create a pendulum by tying a 150-gram mass to a long string. You attach the string to a branch on a tree and start the pendulum swinging. You observe that 10 complete oscillations of the pendulum takes 28 seconds. What is the length of the pendulum? To answer this question, you need to know the formula for the period of a pendulum. The period of a pendulum is equal to 2 pi times the square root of the length of the pendulum divided by the gravitational constant. The acceleration due to gravity. So T is period. It's going to be in seconds. L is length, pendulum length. It's going to be meters. And G is acceleration due to gravity, so it's going to be 9.8 meters per second squared. Plugging everything into the formula. So what is T? What is the period? We know 10 oscillations take 28 seconds. How much does one oscillation take? How long does it take for the pendulum to go forward and backwards one time? That's going to be 28 divided by 10, which is going to be 2.8 seconds. The length is going to be equal to, the length is what we're trying to find out. And believe it or not, we don't even need the mass at all. We don't need a mass for a pendulum. We'll need it if we're trying to identify the spring, because the spring will have mass in its equation, but pendulum only has length. So we can plug it into the equation. 2.8 equals 2 pi square root of length divided by 9.8. And solving for length, length would equal 1.946 meters. So the answer to this question is going to be E, 1.95. Number 11. A cube of steel, 8 centimeters on a side, is heated 750 degrees Celsius. At this temperature, the steel grows a bright red color. If the emissivity of the steel is 0.75, how much power is emitted by the heated cube as electromagnetic radiation? So to find this answer, we're going to need Stefan-Boltzmann's formula. So Stefan-Boltzmann formula says that the heat emitted from an object, or heat gained from an object, is equal to the emissivity of the object times the Stefan-Boltzmann constant times the surface area of the object times temperature to the power of 4. So H stands for heat. Heat is measured in watts. E stands for emissivity. Stefan-Boltzmann constant is given to you on your formula sheet right here. So it's this number right here, Stefan-Boltzmann constant. It's equal to 5.67 times 10 to the negative 8. 5.67 times 10 to the power of negative 8. A is surface area. So it's going to be measured in meters squared. And T is temperature. Remember, temperature in physics is going to be measured in Kelvin. So we're trying to find the heat. That's what we're trying to find. So the heat is equal to the emissivity, which is 0.75, times the Stefan-Boltzmann constant, which we know is 5.67, times 10 to the power of negative 8 times the surface area of a cube with a side length of 8 centimeters. We know the surface area is in meters squared, so convert 8 centimeters into 0.08 meters. And the surface area of a cube is equal to 6 times the side length squared. This is going to be 6 times 0.08 squared. So now we find the temperature in Kelvin. Remember, Kelvin is equal to 273 plus Celsius. So the Celsius temperature is 750 plus 273. Raise that to the power of 4. So what would the heat be equal to? Plugging everything into the equation, we would get an answer of 1,788.46 watts. So we want to find the answer closest to that. That would be letter D, 1780 watts. So the answer to number 11 is going to be letter D. Number 12. For the circuit shown, determine the voltage drop across the 470 ohm resistor. This question has to do with Ohm's law. Voltage equals current times resistance. We know in a series circuit, which is shown here, we add up all the resistors. So if this is R1, this is R2, the total resistance would be equal to R1 plus R2. So in this case, since these two are in the straight line, they would be in a series circuit. So 220 plus 470. So 220 plus 470 would be equal to 690 ohms. So we know the voltage is 24, that's given down here. 24 equals the current times 690. The current flowing through the circuit is going to be 0.035 amps. But we don't want to find the current in the circuit. We want to find the voltage drop across the 470 ohm resistor. So the voltage drop across this resistor. Remember, the voltage drop is also equal to the current times resistance. So we know the current is 0.035 and the resistance is 470 ohms. So we can calculate the voltage drop to be equal to 16.34 volts. So the answer to this question is going to be letter B, 16.3. Number 13. A charge Q with the magnitude of 250 nanocoulombs is located on a line at the 20 centimeter mark, as shown. What is the magnitude of the electric field at point P, located on a line at 80 centimeters at the 80 centimeter mark, due to the presence of charge Q? So the formula for an electric field is equal to the electric force divided by the charge. So E is the electric field. In newtons per coulomb. F is the electric force in newtons, and Q is charge in coulombs. Another thing we need to know is that the electric force between two different charges is equal to Coulomb's constant times the charge of the first point times the charge of the second point divided by the distance between the charges squared. So what is Coulomb's constant? Coulomb's constant is given to us in the formula sheet. Right here. Coulomb's constant. So it's 8.99 times 10 to the 9th. And Q capital and lowercase q are just the charges. So we can plug this formula into the formula at top. So we can get K times capital Q times lowercase q over R squared divided by lowercase q. So the electric field is equal to the Coulomb's constant divided by the charge of the point times the charge of the point divided by the distance between the 2 points squared. This is the formula we need to use. E equals KQ over R squared. K is given to us as 8.99 times 10 to the power of 9. Q is, we want Q to be in coulombs. We're given Q in nanocoulombs. We want that to be in coulombs. So convert that to coulombs by multiplying by 10 to the negative 9. Divided by the distance between Q and P squared. Remember the distance, just like in coulombs, the distance has to be in meters. So we know that this is 60 centimeters. What is 60 centimeters in meters? That's 0.6 meters. So 0.6 squared. Just get rid of that. Plugging everything into the equation. Plugging everything into a calculator. You can get the answer 6,243 newtons per coulomb as the answer. That should be in coulombs, not over 3. So the closest value to this answer is going to be E, 6,240 newtons per coulomb. So the answer to number 13 is going to be E. Number 14. A 24 centimeter length of wire carries a current of 14 amps in the positive X direction. A magnetic field with a strength of 650 microteslas is directed in the positive Z direction, which is out of the page. What is the magnitude and the direction of the force acting on the current carrying wire due to the magnetic field? So we want to find the magnitude and the direction. Let's first find the direction of the magnetic force. To find direction, we're going to need to use the right hand rule. The rule basically says, take your right hand, stick your thumb out, stick your fingers out. The thumb will be the current. The fingers will be the magnetic field, and the palm will show the magnetic force. So we want to find the direction of the magnetic force. So take your right hand, point your thumb to the right. With an open thumb, point your thumb to the right. So your hand should be looking, your thumb should be pointing to the right. And looking at these dots, dot means out of page. And I'll explain to you what that means. So out of page, think of yourself standing in front of the page, of the screen. This is like big screen called the page. It's in front of you. Out of page means pointing away from the page towards you. So you want to so the magnetic field is going out of page. So that means these fingers must be pointing towards you. So using that in mind, we know your fingers must be pointing towards you and your thumb must be pointing to the right. So if you draw your hand out like that. So pretend this is your face. Your fingers are pointing towards your face and your thumb is pointing to the right. Where is your palm facing? Your palm is going to be facing downwards. That's the force. The force is going to be going down in the negative Y direction. So we can eliminate answer choices A and D because those are in the positive Y direction. So again, this I'll draw in a green arrow. That's where the thumb should be pointing, to the right. And these dots mean out of page. That means your fingers, the 4 fingers, are pointing away from the page, so towards you. And that means your palm's going to be facing downwards. Now that we know the direction of the current, we want to find the magnitude. The magnitude of the current can be found using this formula. Force equals current times the length of the wire times the magnetic field through the wire times the sine of the angle. So let's just say we have the wire. We have current flowing through it. Current of I amps. And there's a magnetic field flowing through this wire. the wire has a length L, and the angle between the current and the magnetic field is theta. Those are the units for this equation. And remember the standard units. So force has to be in newtons. Current has to be in amps or amps. Length has to be in meters. And the magnetic field has to be in Teslas. So plugging everything into the equation, we want to find the force is equal to the current, which is 14 amps, times the length of the wire, which is 0.24 meters, times the magnetic field through the wire, which is 650 microteslas. So convert that into Teslas. And we know that its perpendicular is directed in the positive z direction. So it's actually directed perpendicular to the wire. So it's going to be sine 90 degrees, which is just this is going to just equal 1. So the force is equal to 14 times 0.24 times 650 times 10 to the power of negative 3, which is 2.184 newtons. So the answer is going to be 2.18 newtons down in the negative y direction. So the answer to number 14 is going to be B. Number 15. A laser beam, which is naturally vertically polarized, has an intensity of 500 watts per meter squared. The beam is sent through a polarizer whose axis is oriented at 32 degrees with respect to the vertical. What is the intensity of the laser beam after passing through this polarizer? So we know the laser beam is already polarized. So before that, let's actually explain what polarization is. Normally, light is unpolarized, meaning it travels in every direction. There's no set direction of the light. So it's completely unpolarized. It passes through a certain angle with a polarizer with a certain angle. The angle is in respect to the midline. So 32 degrees would actually be 32 degrees with respect to the midline, right here. So it's sent through the first polarizer, and one key property to note is that regardless of the angle of this polarizer, we don't care what the angle of the polarizer is. If this light has an intensity of I naught, the light that exits the polarizer has the intensity of 1/2 I naught. So if the initial intensity is going to be 10 watts per meter squared, the final intensity is going to be 5 watts per meter squared. But here's the thing. That's for unpolarized to polarized. Also, one more thing, polarized light is denoted like this. It's just denoted as an arrow in the direction. So in this case, the arrow is going this way, so the arrow in the direction is going to be going this way. But this is going from unpolarized to polarized. But the question is saying that's already polarized. So we're going from a polarized light beam to another polarized light beam. So we don't just do 1/2 IO. I not. We use another formula. I2 is equal to I1 times cosine squared theta. This is the formula we used when we're doing polarized light to polarized light. So I2 is equal to final polarized light, final intensity of polarized light. This is in watts per meter squared. I1 it's the initial intensity of, again, polarized. That's the key difference. The initial intensity is also polarized. So, key word right there. Also with watts per meter squared as a unit. And theta is the angle between the midline and the polarizing angle. So this green angle I'm drawing right here. So Theta is the angle. So using this formula, we know that the final intensity is I2, the initial intensity is 500. Cosine squared of what is the angle? The angle is 32 degrees with respect to the vertical. So we have 32 degrees here. Plugging this into a calculator, we will get a final intensity of 359.59 watts per meter squared. This is very close to answer choice C, 360 watts per meter squared. So the answer to number 15 is going to be letter C. Number 16. A butterfly sits 29 centimeters to the left of a diverging lens. The lens has a focal length of negative 18 centimeters. What is the magnification of the image of the butterfly formed by the lens? So we have a diverging lens, and we have a butterfly here. So the butterfly is 29 centimeters away from this lens, and the lens has a focal length of negative 18 centimeters. Remember the lens equation is always going to be used for any of these problems. It's equal to 1 over the focal length equals 1 over the distance between the object and the lens plus 1 over the distance between the image and the lens. So what is the focal length? The focal length is equal to negative 18 centimeters. What is the distance of the object and the lens? That's going to be that's going to be 29 centimeters because the butterfly is 29 centimeters from the lens. And now finally, what is the distance between we're trying to find the distance between the image and the lens. So solving for the distance between the image and the lens, you'll get negative 11.106. So clearly it's a virtual image. So now we want to find the magnification. What's the formula for magnification? We know you need to use this formula. That's an important formula, so I'm just going to circle in red. The magnification formula is equal to negative di, which is the distance between image and the lens, divided by do, distance between object and the lens. So the distance between the image and the lens we know is negative 11.106. The distance between the object and the lens is just 29. So plugging that into a calculator, you're going to get a magnification of 0.383. So the answer to this question is going to be D, 0.383. Number 17. The energy level for a newly discovered element is shown below. Atoms of this element produce a strong spectral line with a wavelength of 713 nanometers. Which transition on the energy level diagram is responsible for producing this strong spectral line? So I'll give you guys a brief description of what the question's talking about. So let's just say that's the black dot's the nucleus, and you have atom with, say, 3 shells. We have an electron in the second shell. I'll draw it in green to make it easier to understand. We have an electron. When electrons gain energy via light or other waves, it moves up an energy shell. Actually, I'll just erase this. This electron moves up an energy shell and goes from the second to the third energy shell. So it gains energy. But electrons like this are generally a little unstable. So they tend to go back down to their neutral state. And when they do that, they end up releasing a specific amount of energy. So they release some energy. So this spectral diagram is showing the transition where the light can release energy. So if the light goes from a 2,3p sublevel down to a 1,1s sublevel, it releases 1.74 electron volts of energy. If the light goes from 3.1s sublevel to a 2,3p sublevel, it will release 2.76 minus 1.74. So it would release 1.02 electron volts of energy, because that's the difference between these two numbers. So if the light absorbs a wavelength of 713 nanometers, how much energy would that be absorbing? 713 nanometers. So what's the formula to find energy of a wave? The formula for an energy of a wave is Planck's constant times the frequency of the wave. And what's the formula to find the frequency of the wave? Let's use another formula. Speed of light, the speed of the wave equals the frequency of the wave times the wavelength. In this case, the wave is a light ray. So the speed is actually going to be the speed of light, which is a constant. And we're given the wavelength. We're given the wavelength and we have the constant. We can write f in terms of c and lambda, and substitute that into the initial equation on top, and get hc over lambda. So we can get this formula to find energy. And we know everything. We know everything here. H is Planck's constant, which is one of the constants given to us here. Planck's constant. The speed of light in a vacuum is also given here. So we have the two constants. We have h and c, and we're given lambda. So h is going to be equal to 6.626 times 10 to the negative 34, while c is 3 times 10 to the 8th. Divide by the wavelength. Remember, the wavelength has to be meters. So 713 nanometers is equal to 713 times 10 to the negative 9 meters. So plugging everything into a calculator, you'll get energy equals 2.788 times 10 to the negative 19 joules. That's the amount of energy that will be released after the electron goes from the excited state to the ground state, after it absorbed the light ray. But we don't want our energy in joules. We want our energy in electron volts. Luckily, you can convert joules to electron volts easily, as the constant's also given to you in this sheet. Where would that be? Electron volts, right here. 1 electron volt is equal to 1.602 times 10 to the negative 19 joules. So we can convert joules into electron volts by doing this. For every 1 electron volt, plugging that into the formula, we can get 1.74 electron volts. That is the energy drop. We want an energy drop that equals to 1.74 electron volts. Now let's look at all the options we have. Letter A is from 3.1s to 2.3s. So I'll draw in red. 3.1s to 2.3s. 2.76 minus 1.44. The difference is going to be 1.32 electron volts, which is not what we're trying to find. We're trying to find 1.74. How about 3.1s to 2.3p? Right here. Here you'd have 1.02 electron volts. Again, that's not what we want. 2,3p to 2,3s. So you have 1.74 to 1.44. You'll have a difference of 0.3 electron volts. I'll write that on the side here, 0.3 electron volts. Again, not what we want. 2,3p to 1,1s. 1.74 minus 0, you will have a difference of 1.74 electron volts. So that matches with what we got here. So the answer to this question would be option choice D. And if we see letter E, 2,3s to 1,1s, you have a difference of 1.44, which is not what we want. So the only option in this case would be answer letter D. Number 18. Positronium is the bound state of an electron and its antiparticle, a positron. It exists for only a brief period of time, after which the electron and positron annihilate one another, producing a pair of gamma rays. Which of the fundamental forces is responsible for the existence and decay of positronium? So positronium is when a negatively charged electron and a positively charged positron are attracted to each other and then release off gamma rays after they annihilate each other. So, which of the following forces allow these two particles to attract to each other? Since they're both opposite charges, the only force that would be possible is the electromagnetic force, because that force deals with the attraction or repulsion between opposite or same charges, respectively. So the answer to number 18 was going to be A, the electromagnetic force. Number 19. A large bird flies in a straight line for 10 seconds. Shown below is a plot of the velocity of the bird as a function of time for those 10 seconds. What's the instantaneous acceleration of the bird at t equals 5 seconds? So let's draw a line from t equals 5. And we know, if you guys have done calculus, you might know that acceleration is the slope of the velocity curve. So the velocity time curve, if you want to find the acceleration from that, you want to find the slope of the velocity time curve. So in this case, we want to find the slope at 5 seconds. So I'll draw that in a green line. So you want to find the slope at this point. But since this is a straight line, we can actually just find the slope of this entire straight line to make it a lot easier. To find the slope of the straight line, the rise is 4 and the run is 4. So rise over run is going to be 1. So the slope of this line is going to be 1. So instantaneous of the acceleration of the bird at t equals 5 seconds is going to be 1 meters per second squared. Number 20. Shown below is a plot of the electric potential V produced by a point charge as a function of the inverse of the distance from the point charge. Based on the data, determine the magnitude of the point charge Q. So we're given the voltage or electric potential and the inverse of the distance. So what would the slope of this line be in terms of those two? The slope of the line is equal to the rise divided by the run, or change in y divided by change in x. What is the change in y? That's the electric potential, so that's voltage. And the change in x is the inverse distance, so that would be 1 over meters. So the slope is essentially equal to voltage times meters. To answer this question, we're going to need to know a couple of concepts. The electric potential energy is equal to Coulomb's constant times charge 1 times charge 2 over the distance. So that's one formula you need to know. And the other formula is voltage equals energy divided by charge. Using these two formulas, let's plug both formulas in together. Change in energy, we can plug into energy here. So voltage equals Coulomb's constant times charge 1 times charge 2 over the radius divided by charge 2. You would get Coulomb's constant times charge 1 divided by the radius. So voltage equals Coulomb's constant times charge divided by radius. Multiplying radius to both sides, you can get voltage times radius equals Coulomb's constant times charge. Keep in mind, when I say radius, I don't actually mean the radius of a circle. I mean the distance between the charge and a specific point. So radius is actually equal to meters in this case, like this unit right here. So I could actually replace R with M. Vm. So I have this equation here. What can I do with it? Notice that I have Vm. That's equal to the slope. So the slope of the line is equal to K times the charge. And I can set charge alone in the equation by dividing both sides by K. So I can get charge equals slope over Coulomb's constant. Which, if you don't know, one second, let me erase all three of these. Coulomb's constant is this right here. So we need to find slope divided by Coulomb's constant. What's the slope of this line here? We need to take 2 points on this line. We'll take the first point as the origin, just to make it easier. So the first point is 0, 0. Let's take the second point. Let's just say this point over here. So if this point is 0, 0, this point would be 1, 250. 1, 250. So what's the slope between 1, 250 and 0, 0? Slope would just be equal to 250. So the slope is equal to 250. And what's Coulomb's constant that's given to us in the formula sheet? It's 899 times 10 to the 9th. So 8.99 times 10 to the power of 9. Plugging all this into a calculator. You would get charge equals 2.78 times 10 to the power of negative 8 coulombs. But you want to find the answer in nanocoulombs, not coulombs. So you multiply this by 10 to the power of 9. So Q would actually equal 27.8 nanocoulombs. So the answer to this question would be A, 28 nanocoulombs. And we're finally done with number 20. So we're done with the entire physics section. And if you had started from biology to chemistry to physics, you'd be done with the entire exam by now. I hope you found this video useful and you guys learned something new. And if you have any questions or any doubts, feel free to let me know in the comments down below. And if you found the video helpful, please leave a like and subscribe, as that would encourage me to make more of these types of videos. I'll see you guys on my next video where I cover the invitational meet B for UIL science.